In this video, we're going to talk about galvanic cells, which are also called voltaic cells. So, what are they? Well, galvanic cells are devices that use a chemical reaction to create electricity. Specifically, the type of chemical reaction that they use is called an oxidation-reduction reaction, but we'll talk more about that later. Now, galvanic cells may be totally new terms for you, but I'm willing to bet that you use these devices almost every single day of your life. So, let's learn more about these devices and see how chemical reaction can create electricity. Okay, so I think for the rest of this video, I'm just going to call this as galvanic cell. Alright, so now I want to talk about the parts of a basic galvanic cell, one that you could actually make in the lab. So here's what they are. First, we start with 2 beakers of water, and into one of them, we dissolve some zinc sulfate to make a solution. And then into the other, we dissolve some copper sulfate and make a solution with that. So we have got these 2 solutions, and then we take a piece of zinc metal, like this one right here, and put that in the zinc sulfate solution. And then over here, we take a piece of copper metal and we put that in the copper sulfate solution. The next thing we do is we take a metal wire and we use that to connect the 2 pieces of metal together. And when we do this, something amazing starts happening. Electrons start moving through this wire. They move from the zinc metal into the copper metal. Now, this is a big deal because moving electrons are what make electricity. So when we hook this wire together with the pieces of metal and electrons start moving through it, we have electricity. So, let me show you what's one. This is a magnification of the area here. These zinc atoms are on the edge of the piece of the zinc metal, and then these zinc 2+ ions are in the solution. They are part of the zinc SO4 solution. I'm not showing the SO4 here. I just want to focus in on the zinc, so zinc ions in the solution, and these zinc atoms in the piece of zinc. Then, over here, we have these Cu2+ ions are in the CuSO4 solution. They are dissolved here, and then these copper atoms are on the edge of this piece of copper here. Okay, so we have got a wire that connects the zinc and the copper, and we have said that when we hook everything together, electrons start flowing through this wire. Well, why is that? Well, when we connect these 2 pieces of metal with wire, it kind of starts a tug of war between the zinc and the copper. They're having a tug of war for the electrons. One of them wins and one of them loses. It turns out that Cu2+, these atoms here, Cu2+ has a really strong pull for the electrons, but then on the other hand, this zinc has a weaker pull for electron. So in this tug of war, Cu2+ ends up winning. Let me show you how this happens. So Cu2+ really wants electron. So it's kind of like it calls over here to zinc, which has a weaker pull on the electrons, and says, "Hey zinc, give me some of your electrons." And zinc is kind of weak, so it's like, "Oh, okay." And what happens is, let's say this zinc atom here gives away 2 of its electrons, and these electrons enter the wire and move towards the copper. Now, when zinc gives away these 2 electrons, it causes its charge to change. It's lost 2 electrons, so it gets a positive charge and it becomes zinc 2+. Now, changing from neutral, zinc 2+ has a big effect on this atom. And that's because neutral atoms make up solid metal, but metal ion usually dissolve in water. So, after this zinc atom turns zinc 2+, because it lost these electrons, it's no longer part of the solid metal anymore, and it floats off, it dissolves into the solution. Okay, so that's what happens to the zinc. Then over here, these electrons make their way down the wire to the copper, and one of these Cu2 plus ions, which really wants electrons, is going to come over here, and these two electrons are going to be added to the Cu2 plus ion. Gaining these two electrons is going to get rid of that 2 plus charge that was on the copper, and that is going to turn it into a neutral atom, which means that it is no longer going to be able to dissolve in solution, and it's going to become part of the solid copper metal here. Okay, so that's what happens to the copper. Now, notice that for this whole process to happen, electrons have to move through this wire, and that's where the electron movement causes from. Let's see that one more time. So zinc loses 2 of its electrons here. Those move through the wire, loss of those 2 electrons causes zinc to take on a 2 plus charge. It is then going to dissolve in the solution. These 2 electrons are going to move over here to copper, and one of these Cu2 plus ion that really wants electrons is going to come. It's going to take them in, and that is going to get rid of the Cu2 plus. It's going to get rid of the 2 plus charge, and this neutral copper atom is now going to become part of the solid piece of copper metal, so that is where this electron movement through the wire is coming from zinc. Zinc loses these 2 electrons. They move through the wire, creating electricity. They come over here and they join up with a Cu2 plus, turning it into a neutral copper. We have these electrons moving through the wire here, creating electricity. So that is how we get electricity from these electrons moving from the zinc over here into the copper. And if this happens long enough, we actually see these 2 pieces of metal charge, right? Like this zinc atoms keep coming off of this piece of zinc, so it's essentially dissolving, and over time what we'll see is that this piece of zinc actually start to dissolve it off, get small and smaller. But then on the other hand, those Cu2 plus ions are coming out of solution and are attaching to the solid copper, and they are going to make this piece of solid copper bigger and bigger. And so, if we let this voltaic cell come for long enough, we'll eventually see that these 2 pieces of metal actually change size and shape.